Good day, viewers. Dauda Malek is my name, and I'm your statistics tutor this afternoon. In today's tutorial, we are going to look at normal distribution. So with normal distributions, we have to have our standard normal table. So this is my standard normal table that we are going to use to find areas. Now let's proceed. With normal distribution, we are saying that a normal distribution is a continuous distribution. A normal distribution is a continuous distribution. A normal distribution is a continuous distribution. So with normal distribution, we have properties of normal distribution. Now let's look at the properties of normal distribution. The first property of normal distribution is that it has a bell shape. That's the first property. The second property is that the total area under the curve is equal to 1. That's the second property. The third property is that it is symmetric. And when we say a distribution is symmetric, it simply means that the mean, the median, and the mode, they are all equal. The fourth property is that it has inflection point. When we say inflection point, it's a point at which the normal curve rises and falls. So I'll draw a distribution and I'll show you where the inflection points are located. The fifth property is that the normal curve approaches but never touches the x-axis. So this NC here means normal curve. And the last property is that with normal distribution, the mean varies. So please, these are the properties of normal distribution. I'll draw a distribution here and I'll explain all these properties to you. So this is my normal distribution. This curve you see here is called the normal curve. So if you hear a normal curve and a normal distribution, this is what we mean normal curve. And in between here is my mu, that's the mean. This line is called the x-axis. This is the x-axis, the line here. So I'm going to explain the properties to you. I think that it has what? A bell shape. So you see this one, the normal curve is in the form of a bell. That's why we're saying that it has what? A bell shape. The total area under the curve is equal to 1. So this is the curve. Here, the places here, this is under the curve. And you are saying that the total area, so total area is equal to 1. So all the area here under this curve is equal to 1. It's symmetric. And I'm saying that when we say something is symmetric, it means the mean, the median, and the mode, they are all equal. So assuming here our mean is 10, it means the median is also 10 and the mode is also 10. Why? Because they are symmetric. The fourth property is that it has inflection point. I'm saying that the inflection point is a point where the normal curve rises and falls. So the curve starts rising from here and it falls from here. So these places are called the inflection points. The fifth property is that the normal curve approaches but never touches the x-axis. So you see, this is my normal curve. This is my normal curve, and this is my x-axis. It always approaches the x-axis, but it will never touch it. So if you have, or if you draw your own normal curve, and your normal curve touches the x-axis, it means it's not a normal distribution. So assuming you draw a curve like this, and you bring your x-axis like this, this is wrong. This is not a normal distribution. Why? Because in a proper normal distribution, your normal curve should approach the x-axis, but it shouldn't touch it. So in a case where yours touches, it means it's not a normal curve or a normal distribution. Okay, and the last one is that with normal distribution, the mean varies. It means we can have 10 different sets of normal distributions whose mean will vary. So let's say we can have 3 distributions like this. So I have here 3 distributions, and we are saying that with normal distribution the mean varies. So here, if assuming with the first distribution 1, 2, 3, with the first distribution, if the mean is 10, here the mean can be 15, and here it can be 50. So here it means that with normal distribution the mean varies. So that is all under normal distribution. So our next step is standard normal distribution. With the standard normal distribution, it's the same as the normal distribution, but it has only 2 properties that differ it from the normal distribution. So let's go to the standard normal distribution. Okay, so this is my standard normal distribution. Okay, so as I said, the standard normal distribution is the same as the normal distribution, but it has some 2 properties that differ it from the normal distribution. It is also continuous distribution as the normal distribution is. Okay, so the properties here that we will look at are only 2 properties. The first property of the standard normal distribution is that it has a mean of 0 and a standard deviation of 1. So with standard normal distribution, it has a mean of 0 and a standard deviation of 1, meaning that with standard normal distribution, the mean is static. So under here, we can have about 3 distributions like this. We can have about 3 distributions like this. We have distribution 1, 2, 3. These are 3 distributions. But with regards to, or with respect to standard normal distribution, it's saying that it has a mean of 0. So although we have 3 distributions, all of them, they are all having a mean of 0. Why? Because with standard normal distribution, the mean is static. The mean doesn't change. But with normal distribution, the mean varies. So you can bear with me that with normal distribution, the three distribution that I drew on the board, they were all having different mean. But here is the case that they are all having a mean of 0, 0, 0, 0. Why? Because the mean is static. And we are saying that it has a standard deviation of what? Of 1. So SD is 1. Here too, SD is 1. SD is 1. And when we talk of the standard deviation, another standard normal distribution, the standard deviation describes the spread of a distribution. It's what? It describes the spread of a distribution. So, let's say we can have two distributions like this. So you see, we have distribution A, distribution B. You can bear with me that this one is more spreader than this one. It means here we'll have the bigger standard deviation than this one. Why? Because we are saying that the standard deviation describes the spread of a distribution. So that's the first property of standard normal distribution. Let's go to the second property. The second property is that the x value can be transformed into a z-score. So the second property of standard normal distribution is that the x value can be transformed into a z-score. And when we talk of a z-score, we have a formula for a z-score. The formula for a z-score is z, that's what the z-score is equal to value minus mean over standard deviation. So the value minus mean over standard deviation. Here mathematically it can be written as z is equal to x representing the value minus mu representing the mean over standard deviation. So these are the two properties that distinguish the standard normal distribution from the normal distribution. One, it has a mean of 0 and the standard deviation is of what? Of 1, which is static, it doesn't change. And two, the x value can be transformed into a z-score. Please, I hope you are okay. Now, let's go to finding areas on the standard normal table. Finding areas on the standard normal table. So the SNT means standard normal table. So finding areas on the standard normal table. So we can be given an area, then we find it on what? On the table. So always you'll be given a z-score. So when you're given a z-score, then you go to your table, then you find its corresponding area on the table. So let's say, assuming we've been asked to find this on the standard normal table. We find this area. So if we are asked to find 1.12, if you are asked to find 1.12 on the standard normal table, it's very simple. So you see, I have my table here. These are my tables. So you see, this is a positive number. And the tables there too, we have negative side and we have positive side. So because this is a positive number, I'll take my positive what? Sheet. So 1.12. To find this, or to make it easier in finding it on the table, you first is what? Here means is 1.1 plus 0.2. So 1.1 on your vertical axis and 0.2 on your horizontal axis. If you are finding 1.12, you find 1.1 on your vertical axis and you find 0.2 on your horizontal axis. So this is my vertical axis, this is my horizontal axis. So 1.12 means I'll find 1.1 on my vertical axis. So 1.1 is here. This 1.1. So 0.2. 0.2. So point 1. Okay. So 0.02. 0.02. So 0.02 is also here. It's also here. 0.02 is also here. So my 1.1 is here, and 0.02 is also here. So you trace like this. So my answer is 0.86864. So this on the table is 0.86864. That's how we find the areas or the z-score on the table. Let's solve another example. So you can also be asked to find negative 0.24. So if you are asked to find negative 0.24 on the standard normal table, the interpretation is you find negative 0.2 then plus 0.04. So you find negative 0.2 on your horizontal axis, then you find 0.04 on your vertical axis. So where they intersect, the area there becomes your answer. So because this is negative number, I have to take my negative table. So my negative 0.2 is here. Negative 0.2, yeah, negative 0.2 is here, and my 0.04 is also here. So this one, the first one on your vertical axis, and here on your horizontal. Okay, so negative 0.2 is here. I have my negative 0.2 here, and 0.04 is also here. So you trace from 0.04 down. This 0.2, so where they intersect. So my figure here is 0.40517. So 0.40517. So this becomes the area for negative 0.24. So that is how we find the areas on the table. Okay. And on the tables too, you can be asked to find a z-score, or you can be asked to find an area on the left of z or on the right of z. Whenever you are asked to find an area on the left of z, it means the answer you get on this table is your final answer. When you are asked to find an area on the left of z, the answer or the area you find here is your final answer. But when you are asked to find an area on the right of z, it means the answer you find here is not your final answer. You have to deduct this answer or the area you find here from 1 before you can get your final answer. Let's break example so that you understand what I'm trying to say. So assuming we are asked to find an area. So find an area under the standard normal table to the left of z. So if you are asked to find an area under the standard normal table or under the standard normal curve to the left of z, and assuming the area or the number you've been asked to find is negative 0.99. So if you are asked to find negative 0.99 on your left of z, it means the answer you get here is your final answer. So here you find negative 0.9 on your vertical axis and 0.09 on your horizontal axis. So where they intersect, where they meet, that area there becomes your final answer. So I have my negative 0.9 here, and I have 0.09 here. So I trace it. My answer is, so here on the table is 0.16109. So finding 0.99 on the left of z. On the sheet, I got 0.16109, and this is my final answer. Why? Because it is on the left of z. So whenever you are asked to find an area on the left of z, the answer you get here becomes your final answer. Or whenever you are asked to find an area and there is no instruction that find it either to the left or to the right, you'll be asked, let's say, find an area, and they give you the area. The answer you get here is your final answer. But, you see what I'm saying, but when you are given to find an area on the right of z, with the right of z, the area you find here is not your final answer. To get your final answer, you would have to deduct that area from 1 before you can get your final answer. So assume you ask, let's say, find an area under the standard normal table to the left or to the right of z. To the right of z is, let's say, is 1.23. So assuming we will ask to find an area under the standard normal table to the right of z is 1.23. So we are finding this table. Because it is on the right of z, the answer we find here is not our final answer. We have to deduct it from 1 before we can get our final answer. So 1.23 on the table is, I'll find 1.2 on my vertical axis and 0.03 on my horizontal axis. So 1.2 is here. This is my 1.2. And this 0.03. So here they will come they will meet here. So here the answer on the table is 0.89065. So 1.23 on the table is 0.89065. Because I am asked to find it on the right of z, this is not my final answer. If I want to get my final answer, I have to subtract this one from 1. Then the results will become my final answer. So to get your final answer, you subtract this one from 1. So it becomes 1 minus 0.89065. So 1 minus 0.89065. Okay, so my final answer is 0.10935. So this becomes my final answer. Why? Because I am asked to find it on the right of z. So whenever you are finding area on the right of z, the answer you get on your table is not your final answer. You have to subtract it from 1 before you get your final answer. So please, that's how we use it. So you see, with all this thing I've been doing, our first example, that's the first example, that's with negative 0.99. We got 0.16109. Yeah. So with our first example, we got 0.16109, and with the second example, this is on the left of z, and this is on the right of z. That the second example is on the right of z, and the area was, the z score was 1.23, and we had 0.10935. So with this, I'm going to show you how to use the calculator to find all this. I know when it's the exam times, maybe there will be a situation whereby they will not give you this one on time. So we have the smartest way of using the calculator to find it without using the table. So I'm going to show you that one. So you see, we are doing statistics. So first of all, you have to switch your start mode on the calculator. To switch your start mode on the calculator, you press on mode. Start is 3, so you press on mode, then you press 3, then you press 1, then you press AC. So mode 3 1. You see, when you look on the calculator, my start mode is on. The start mode is on the calculator. Right now we are doing standard normal distribution, and we have distribution on the calculator. So to go to distribution, we are doing statistics. So you press on shift, you press shift, then you press 1. So after pressing Shift and Y, you see a content will open. The first one is type, second is data, 3 is sum, 4 is var, 5 is distribution. So because we are doing distribution, then you press on 5. So when you press 5, another content will open. With that content, we have 1 is P. We have 2 is Q. We have 3 is R. And we have 4 is T. But for the purpose of these workings, we are using only 1 and 3. 1 is P and 3 is R. So I'm going to explain them to you. You only use P on a calculator. You only use P when you are asked to find an area on the left of Z. So whenever you are asked to find an area on the left of Z, you use P to find your answer. And we use R whenever you are asked to find an area on the right of Z. So P is on the left of Z, and R is always used whenever you are asked to find an area on the right of Z. So assuming the first area was what? On the left of Z was negative 0.99. So I'm going to point it there and verify if you get the same answer that we had here. So I'm going to start afresh. I'm saying, first of all, you have to switch your start mode on. So to switch your start mode on, you press on mode, you press 3, you press 1, then you press AC. Now my start mode is on. We are doing statistics. So I'll press Shift, then I'll press 1. A content will open. We are doing normal distribution. Distribution is 5 on the calculator, then you press on 5. When you press on 5, another content will open where we have P, Q, R, and T. And I was saying that for the purpose of this work, we are using P and R. And we use P when we are asked to find an area on the left of Z. So we are finding this area on the left of Z, and the area or the Z score is negative 0.99. So P is 1 on the calculator. So you press 1. You see there's a content that has opened. Then you point in that figure there. Is what? Negative 0. So negative 0.99. Then you close the bracket. Then you point equal to. So when I point the equal to, the answer in the calculator is 0.16109. You can attest with me that it corresponds to this answer, meaning I'm correct. So in the absence of this standard normal table, you can also use the calculator to find areas. That's what I'm showing you. So on the calculator, when I point, I got 0.16109. And you can bear with me that it corresponds to this answer, meaning I'm correct. Please, I hope you understand what I'm trying to show you. Okay, then we are asked to find an area on the right of Z. And on the right of Z, the Z was 1.23. So because it is on the right of Z, we will use what? R on the calculator. So you press your Shift 1, then you go to distribution, that is 5. Then you go to R. R is 3. So you press 3. Then you point your answer there, or the number there, that's what? 1.23. So 1.23. Then you close the bracket. When I point, my final answer on the calculator is 0.10935. You can bear with me that this answer corresponds to this answer, meaning that I'm correct. So that is how to use the calculator in the absence of the standard normal table to find your Z or to find your areas on a standard normal table. So please, I know practice makes man perfect. So practice and you become perfect, so that in the absence of this standard normal table, you can use the calculator to find it. Now, with these same areas, you can be given a table to find it. So I forgot to tell you one thing. When you are using the calculator to find an area on the right of Z, you don't need to subtract the answer from 1. When you point it there, the calculator will give you correct answer. It will give you straight answer without you subtracting the area from 1. That's the essence or the benefit of you using the calculator. When you're using the table, and you are asked to find it on the right of z, you have to subtract the area you find here from 1 before you get an answer for the right of z or on the right of z. But whenever you are using the calculator, when you point the figure there, it will just give you straight answer. You don't have to deduct it from 1 to get your answer. With this same way, you can be given a table like this. Then you see, they will shade this side. They will shade here and they will write, let's say 1.54 here for you to find. So, you see, this is right. They've shaded right side. So, because they've shaded right side, it means you find it on the right of z. So with this, you just take your table, then you find 1.5 on the vertical axis, then you find 0.04 on the horizontal axis. So 1.54 on my table is 1.54 on my table. So this one, because it is on the right of z, the answer is 0.93822. And because we are using the table and it's on the right of z because they've shaded right side, this is not our final answer. We have to subtract this one from 1 before what we can get our final answer. So it's what? 1 minus 0.93822. So 1 minus 0.93822. My final answer is 0.06178. So this becomes my final answer. Why? Because I'm asked to find it on the right of z. Okay. So with this same thing, whenever you are using the calculator, you just need to what? Switch your start mode on. Then you press shift and 1. You press 5. You go to what? 3. 3 is R. So on the right of z is what is? Then you press 3. You point the figure, that's what? 1.54. And the calculator is 0.06178. So it's the same as this. Okay. We can also have a table like this or a distribution like this. Then they will see the left side. So you see this one is on the left of z. So when they say the left side, it means you are finding the area on the left of z. So you just need to find your area here, or you use the calculator to find it. Then you get your final answer. Please, I hope you get the difference between the table. So this is on the right of z because they shaded the right side. This on the left of z because they shaded what? The left side. Please, I hope you are okay. Okay. So we have another table here. So let me. I'm going to draw 2 tables here. Okay, so please, let's take a critical look at these 2 distributions. They are different altogether. Here we have the right side shaded, the left side shaded, and the middle is left open. Here, all the right side and the left side, they are left open, but the middle is shaded. So whenever you are given a distribution like this, to find, because they have shaded the middle, please, because they have shaded the middle, you use your table to find this area. So you use your table to find 1.12. So assuming I'm using my calculator to find it. So by using the calculator with 1.12 on the calculator, okay, 1.15 rather, 1.15. Sorry, 1.25. Okay. So with the 1.25 on the calculator is 0.89435. So this one on the calculator is 0.89435. It's the same as on the sheet. And negative 0.6 This one to negative 1.06, so negative 1.06. Negative 1.06. This one too on the calculator is, this one is 0.14457. So please, when you are given a table, a distribution whereby the middle is seated, you find this, then you find that. If you are done, then you subtract the smaller one from the bigger one. So right now with 1.25, I got 0.89435. With negative 1.06, I got 0.14457. This one is smaller than this one. And you see, we always have only one z. We don't have two z's. We have two z's here. We have to get only one z. And because the middle is shaded, you have to subtract the smaller area from the bigger area so that you get only one area. So this one is smaller than this. So it will be 0.89435 minus 0.144. So it will be 0.89435 minus 0.14457. This one is bigger than this one, so we subtract the smaller one from the bigger one. So with this 0.89435 minus 0.14457, my answer is 0.74978. So this becomes my final answer. So whenever you are giving a distribution whereby they shaded the middle, you find your z here and you find your z there, then you subtract the smaller one from the bigger one, then you get your final answer. So this is whereby the middle is shaded. Now let's come back to this one. This distribution is different from this distribution. With this distribution, the right side is shaded and here to the left side is shaded. So here it means you will use or you find this on your right side. So finding this on your right side, you will find 1.17 on the table, and the answer you get, you subtract it from 1, or you can use the calculator to find it. By using the calculator with 1.71 on the calculator, 1.71 on the calculator, I had, with this one, I had 0.043633. So 1.71 on the calculator is this number, and it's on my right of z. So when you are using the table, you find it 1.71 on the what? On the table. Then the area that you get, you have to subtract that area from 1 because it is on your right of z. Here is on my left of z, so it means the area I will get here is my final area because it's on my left of z. Or you can use the calculator to find it. So with using the calculator, on my left is I will use p. P is 1. So negative 1.31. So this 2 on the calculator is 0.095098. So negative 1.31 on the 6 is 0.095098. And I always say that we only have one answer for z. Here we have two z's here, so it means we have to make sure that our z becomes 1. So note, whenever you are giving a distribution whereby the sides are being shaded, when you find this side and you find that side, we add them. So whenever we have two shaded sides, we add them. So here you add this one to this one. So plus 0.043633. So when I added this one to this one, my final answer was 0.138731. So this is my final answer. So listen, I'm about to conclude. So when I'm giving tables like this or distributions like this, this one is different from this one. When they shake the middle, it means you will find these two areas. And here they are all on the left of Z. So you find these two areas. When you are done, then you subtract the smaller one from the bigger one. This is when the middle is shaded. And where the various sides are shaded, you find this one on the right of Z. You find this one on the left of Z. When you are done, then you add the two numbers together. Please, I hope you're okay. Okay, so that's all about normal distributions. And before I finish, maybe in exams too, you can find an areas like this. Maybe they can write something like this. Let's say find the following. Let's say find the following. Find the following. Let's say 1 P bracket Z. This is less than 0.13. So when I ask to find P into bracket Z is less than 0.13, it's the same as on the left of Z. This one is the same as on the left of Z. Sometimes they can bring Z is less than or equal to 0.131. This less than or equal to is the same as less than. They will bring this one to confuse you, and it's the same thing. Second example, maybe P bracket Z greater than 1.31. So this one greater than means on the right of Z. So this one, that's the less than, is on the left of Z, and this one is on the right of Z. And you just use your table or the calculator, then you find it. That's all. You can also get this one too. This is number 3. P bracket 0.1 negative 0.15 negative 0 negative 0.15 is less than Z, is less than 1.31. So you see, the Z is in between these two values. So whenever you are giving questions like this, and the Z is in between these two values, it's very simple. It means you use your table to find this one, and use your table to find this one too. When you are done, then you compare the two numbers, and you subtract the smaller one from the bigger one. So this one is the same as this table. So what I've written here, graphically, this one is the same as this. So whenever you give, like you are giving a question like this, whereby the Z is in between these two values, it means mathematically or graphically it's the same as this one. So you find this one on your left of Z, you find this one on your left of Z, or you find the areas on your table, or you can use your calculator to find it. When you are done, then you compare these two numbers, then you subtract the smaller one from the bigger one. This is how we find areas under the standard normal table. Thank you very much for your time. Once again, Dauda Malek is my name, and I'm glad to have you as my viewer. Thank you.